Today, I'm showing you how to build a multi-agent system for supply chain that solves a 5 billion flower problem. We are identifying and auctioning 43 million flowers a day in real time. To handle that scale, I combine Gemini 3 provision, DeepSeek, PydanticAI, and LangGraph. I'm showing you the complete Python code, how to build a vision agent, synthetic data, simplifying RAG, and use powerful reasoning, plus a full Gradio Dashboard as UI. I'm my own PhD with 20 plus years in AI. I teach thousands how to build real-world AI agents in 90 plus countries. So this is the Python code, including all of the files to build our complete dashboard with Gradio, which has 4 steps. I will show each of the steps. But before dive into this code, let's take a look at why we even need to build this system. Our mission was that 5 billion flower problem. In FloraHolland, world's biggest flower market and auction in Amsterdam, size of a city, we handle 43 million delicate flowers every single day. But the problem is that buyers need to know the species quality and price from one photo instantly. A text box cannot do this. We need basically a solution which is very fast, but it's also low cost. You may wonder, okay, that's a vision problem. You want to identify flowers and then auction the price. Just pick OpenAI or Gemini Pro Vision and then you're done with it because you can just recognize the flower very fast and give it a label. The problem is that it hallucinates a species name, so made up some scientific classification. If you do that, it costs us more than 2 million per day. So that's basically not a solution, it's a disaster. Looking at the problem that buyers have to know the species quality and price from one photo instantly, we have 2 problems, identifying and auctioning. We want to know which type of flower we have. We also want to auction it, meaning that we want to know exactly which price based on so many variables is attached to that flower. And we want to do it also for 43 million flowers a day. So what would be logical to build in this state is to just have a vision model, put it in a vector database, build a RAG pipeline, and then link it to our real-time pricing. But there is a slight problem with that. We need to identify 43 million flowers, but we don't have that database because FloraHolland will not just hand their data to us. But we want to simulate exactly the same situation. So we need to generate this database of flowers with all of the species and descriptions of the flowers and also their pictures. And here is where we use PydanticAI plus GPT-5. What we are going to do is we are going to generate all of the botanical description of the flowers. The cost is very low for the whole thing, 30 cents. And we will create a botanical database JSON. PydanticAI is one of the modules that I teach in my AI Agents Mastery, and it's extremely good in creating structured data. Let me show you how to do it in code. So in Pydantic, we use agent to create and generate this data. We're going to use Oxford pictures of the flowers. So these are all of the species and their category ID, which matches the labeling of those images. The way we do it is we start with an empty database, tell that we want a JSON. We can write that JSON as a file, describe our agent, which is getting all of the setting of a data generation model. It will be an expert and will generate scientific information. Then we will use this agent in a loop for all the categories and get the result, and we'll add it to our database and also generate scientific name and family. So we will have common name, scientific name, family, and native region. And all of that would be in our botanical database. So how PydanticAI ensures that you get a good JSON exactly as you want. You will use just a base model. You will give that structure the way we want it, and then we return it exactly as we want. And also when running agent, we can even give more description of what we want. But mainly this is actually deliver that clean output JSON for us. By the way, I made a complete module of my AI Agents Mastery completely for free. It teaches you how to build AI agents from zero to hero in only 30 minutes, plus a free valuable guide. It's the first link in the description. And if you want, you can also just join my AI Agents Mastery. I would love to see you there. Also, the link is in the description. Now that we have all of the IDs and descriptions and information about those species, we need pictures. We have an Oxford flower. It has 8,000 pictures, all of the pictures, and that matches all of those IDs because we intentionally first got those IDs and generated information for those specific flowers. It can be 8,000 or 8 million flowers. We don't care because we just download them and just put them somewhere. And we just use the IDs, and that makes it very lightweight. You don't need to every time pick up the flower and understand what it is. It's also very cost efficient. Downloading those images is very straightforward. We've got the same flowers also on Hugging Face, which makes it very easy. Hugging Face has this database. You can use just one line of code and download all of those info. If you're not that familiar with Hugging Face, I have a video which is an introduction to Hugging Face. You can check that out. So we make a directory, sure there is an image and a label, and then save that image to a bus. That's it. We can just return how many we have downloaded. I always do a verification. Just take a look at sizes if they are not zero and you know that they exist. Also with our previous step, verification of that one, pick up a sample and see if the data is exactly as you want and that the JSON has been returned in the structure that you want. Now that we got our IDs, our description, the whole JSON, and we have our images, we can now use a RAG to build a database of those flowers. What we do is use ChromaDB, very lightweight and also free, and it makes it searchable. So every time that we search for a specific item, which we need to do for our auction, it immediately goes and finds the top N of that item based on similarity. And because it's text that we are putting there, we need embedding. Embedding basically changes text to numeric. So now we are done with PydanticAI. We are importing ChromaDB and we also use the embedding functions. Here is where we save it. Then we use an embedding function, give the model name, start building a collection, the name and the embedding, and we can give it a metadata. Now we can add all of the species that we had, category ID, scientific name, and more. We add that as collection to the documents, metadata, and we add an ID. Now we have built our vector database, and we can query that with asking any text, so a specific flower or description, and get 5 results. So this specific RAG is simplifying our whole problem because we're working with IDs and not the pictures themselves. It's also an anti-hallucination solution because RAG does not make up things. It just searches the reality as you want, and that's where you always get reliable information. It is extremely important to get the right flower and the right section, and after that then connect all of the information to that. But in one small place we still can have a problem. If we have 5 and then LLM needs to choose one of them, we need also a strong solution, like one of those top 5 needs to be the closest description. And what we can do is use reasoning of one of the best reasoning model right now, Deepseek V3.2, to get the best result, the best description of those 5. So in the configuration, I have this Deepseek version 3.2, which I use from OpenRouter. If you want to know which APIs I need, it is OpenRouter. Later on, we will learn about Gemini and also OpenAI. When I was generating those descriptions with PydanticAI, I can go ahead and use 4.0 mini or 5 nano because it's not extremely complicated. We can also fine-tune the model to those descriptions. Have a very small model which is specialized in the flowers descriptions. And this is where you can find OpenRouter DeepSeek. For more information about DeepSeek, you can go to Hugging Face. So DeepSeek has a sparse attention scalable RL and gives these Olympiad level reasoning. Its performance is as good as GPT-5, but the cost is about 20 times cheaper. So it's optimized for agentic workflow. So now that we've got our database, we can go ahead and build the AI agents orchestration. We're going to build it in LangGraph. We're going to have a vision model, of course, to just understand which image we have. Then we will identify, and then we will use kind of market intelligence, like kind of dynamic pricing for that auctioning part. And then finally, we will gonna do a reporting. You work with a graph, you have nodes and edges, and that's way more intuitive than working only with LangChain. So we're gonna use that graph from the LangGraph, and it's simply building a graph, which has this vision node, identify species node, auction intel, and synthesize it. After adding all of these nodes, we will add the edges, which will connect each of the two nodes together, and then adding an end node. It's really simple, and we compile our graph. And this is how we generate all of these agents. It is one of the modules that I teach in my AI Agent Mastery, and it can handle any kind of complexity. You were going to build in AI Agent Mastery, for example, a complete hospital, which is very complex, but LangGraph just beautifully can handle that. It's a little bit more code intense. You compare it to CrewAI or PydanticAI or OpenAI SDK, but it gives you more control. Let's take a look at our nodes, so our agents basically. The first one is going to get a description. So we'll get a visual description. Then we will have a species identification node, which will look at all of the descriptions, which will go ahead in Chroma and find the top 5 flowers, which will use our Chroma to get those 5 results. And then after that, we can use our Deepseek Reasoning to look at the top matches from our Botanical databases and find the most likely species identification from those. It should give us a confidence. If it's not confident enough, block that from going to production. And we give it a low temperature because we want it to be very predictable, very reliable. Now that we have done the identification, we want to do that auctioning. And for the auctioning, this is more the connection between the prices and the economy calculation for that specific flower. So we will have different databases that will give you those information. You have the family of the price ranges, you have the origin, which hour it is, day of the week, months, day, everything. We want some time multiplier, weekend multiplier, seasonal multiplier, and quality grade. We want a base price and we want a final price. The trend changes, trend direction. This is the information that comes real time. You just combine all of those information, which is completely structured data. The only thing that you need is the ID of that flower, and then you can just do all of this information. And again, it makes it very lightweight. That makes it, of course, also very fast because we need also very fast all of the information. And finally, return quality grade, freshness, last updated, and buyer of the country. So the whole auction information next to that species is completely done here. And the last agent basically put everything together, which will look like this. That's the last node. We get all of the visual description, species, auction information, everything. And we'll write down quality assessment, market intelligence, care instruction, also professional for a wholesale flower buyer at FloraHolland. Now that we've got everything, I have run each step and verify each step. So downloading images, setting up, and then we go ahead and build and test our agents. After the testing was done completely right, put everything in a Gradio user interface, which is very easy to build. Let me show you the user interface. So I've got step 1, generate database. I'm going to generate 32 flowers for demonstration. It's going to start generating all of those flowers and explaining which flowers it's making. And after generating, I've asked it to just show everything, the cost of generation, and then also the file size. It does not matter that this is not very fast because we are generating data to start our process. Normally, you will get the data already from the systems. But this tells you how to generate synthetic data for different industries. For example, in fraud detection, you cannot go ahead and get data. Generating synthetic data can be really useful for you. Then we're going to do image download. Same, this can be completely offline. We don't need to put it on the dashboard. But this makes it also very easy to see what kind of images we have. So we can just go ahead and download just a few images. You would download them and just show it to you. After that, we were going to go to step 3. I said what kind of embedding we are using. We're putting it in ChromaDB. Let's build our vector database. We already built it very fast. And now we are running our agent. Run AI agent, vision analysis, species identification, and market intelligence. Node 1, vision analysis. Next one, node 2, species identification. The report synthesis went from 3 to 4 very fast. And now we are done. So all of the vision analysis, species identification with DeepSeek and ChromaDB, dynamic pricing, and finally we do a report analysis or report synthesis. We do that one also with DeepSeek. We got the vision analysis. What is the primary color? Soft pastel pink. How many petals it has? What are the leaves? The size, the distinctive features, and then the growth pattern. And these are our species identification. It has the name and scientific name, and this is important. It's a confidence, and the reasoning. It explains why it has chosen for that, and this is important for transparency. Market intelligence. What's the price? The trend, volume, origin, Colombia, quality, freshness, and which countries buy this. So this is actually the whole quality assessment, care instruction, everything that I have asked for it. And we can have also some system info. What's exactly our architecture? This is for ourselves, what we have built, and what kind of intention, what kind of architecture we have built. So this is our complete FloraHolland AI agents, our 5 billion, 43 million flowers system, which is really scalable. We do not care how many labels we have because of that simplicity and lightweight nature that we have chosen for our approach. Now that you have seen this project with the solution that I've delivered, I have another 8 projects for AI agents in real world in different industries. It gives you a ton of experience, architecture, the tech, and all of the resources. See you there.